Okay, so this is the first time we teach in the video, so please let me know if there are any problems. For example, you think that this is not clear enough or the voice is not large enough. Okay, so the chapter 7 is about the area and volume. So when you open your book, you will find the new solid we have to learn, which is called the pyramid. Okay, so the pyramid, you can see no matter what kind of base it is, there's a vertex vertically above the base, so it forms a pyramid. Okay, so before we going to start with the volume of a pyramid, we have to deal with something that we have learned before. So let's have a revision. Okay, so what have we learned for the volume? I think all of you have this review for the volume of prism. Okay, if you get a prism like this, you have a base area, you have a height. Okay, this is a prism. And also, we get another kind of cylinder. Okay, the cylinder look like this. Also, it consists of the base area and the height. Okay, and remind you guys that the volume of no matter the prism or the cylinder, we all consider it as the base area times the height. Okay, so by building by this logic, and we'll learn the new stuff for pyramid. Okay, you will see this is the pyramid. Also, you can see the base area right here. We got another kinds of height. Okay, no matter what kind of pyramid, you can still find the base area and the height. Okay, so what is the volume of a pyramid then? I recommend you to watch the video of ETV link, which actually we have been posted on eClass. This ETV link is, you can search the ETV pyramid and sphere on Google. You will find the video. Or actually, what is this about? It is using the daily experiment to show that the water contains of the pyramid, of the prism, and then which is actually 3 times to the same base pyramid. For example, if this 2 is the same base, the water contained in the prism is 3 times to the pyramid. So we get the formula of the volume of the pyramid, which is actually 1/3 times base areas times height, because the relationship between these two is about 3 times. Okay, so when you still need to have a proof, you can watch these activities of 7.1, which is actually, it cut this cubic into 6 pyramids. So the answer for 1 is 6. It cut into 6. So let's say the volume of the pyramids is 3. So actually for the cubic, we actually have 6V. Okay, and see if each of the pyramids is in A for the base area. This is the H for the height. So that means the cubic is actually with the 2H for the height. So if I calculating this with the base area A and with the height for 2H, so we get the 2AH here. So now you can see by 6V equals to 2AH, we can have V equals to 1/3 and then AH. Okay, so if you don't know this proof, okay, I think it's okay because this is a bit complicated. So you can watch this video by using the daily experiment. You can compare this two volume with 3 times. Then it's okay also. Okay, so what we need to know actually is this. The volume of pyramids is 1/3 times base area times height is what we need to know. So that's when we're using this kind of formula. Now, you can try the example 7.1. So first, you can see these pyramids have the base area. They don't need you to calculate. They give you already the base area is 36 cm square. And also, they give you the height. The height now is 5 cm. So by using this formula directly, 1/3 times base area times height. That you can see here. By using your calculator, you can calculating the answer is 60 cm cube. Okay. So you can try to using this formula to do the quick practice. If they giving you this base area to be 48 cm square, and then the height is 3, all you need, the data is included. So how can you apply this? So you can try it yourself. Okay, so for the example 7.2, then you can see what is the data they has given you. They're giving you the volume. They're giving you the size of the base. Okay, because this is the base with a square, actually square-based pyramid. This is 6, this is 6. Okay, so you want to find the height. Okay, so by using this side of this square, so I know the base area should be 6 times 6 equals to 36 cm square. Okay, so now by using the volume equals to 1/3 times base area times height, that means 36 times h. Then I will find that the height will be 10 cm. So we're moving backward. By having the volume, by having the base area, we calculate back to the height. Actually, it's the same thing. So when you're using this formula, more familiar, then you know, no matter you calculate forward or calculating backward, it's also the same things. Okay, so you can see the example 7.3 is a bit difficult because they told you to find the height by not telling you directly. They need you to calculate. Okay, so first we look at these examples. They're giving us a square base pyramid again. Okay, no, this is not a square, so this is a rectangular base, sorry. Rectangular base. And then you can see for this rectangular, the width is 6. The length is 8. Okay, so actually you have the base area already because base area of a rectangle 6 times 8 is 48 cm square. So you have the base area. So you need to find the height in this case. So how can we find the height. We get the slight edge for this is 13, but we want to find the length for VO, which is the height. Okay, so how can we do this? So first, we consider this is a rectangle, and then the diagonal will form right angle triangles. So we're using the right angle triangle, then we know we can use Pythagoras theorem. So 6 squared plus 8 squared will equals to BD squared. That means this is the square root of 6 squared plus 8 squared. You will have 10 cm for this BD, the length. Okay, so we want to find this height. Actually, we need to find the length of BO. Then we can have another Pythagoras theorem to find this height. So by using the property of a square, we know that if this is a diagonal, they bisect each other. So if I find that BD is 10 cm, that means BD should be 10 divided by 2, which is actually 5 cm. Therefore, you will have another right angle triangle for this. BO for 5. This is 13. We get the right angle triangle. So we're using a Pythagoras theorem again. We find that this is actually 12 cm. Okay, then we have solving the problem for A. We finished to find the height of this pyramid. Okay, so we have the base area for 48. We have the height for 12. So we can using this directly formula. So 1/3 times base areas times height. Then you will see the answer is 192 cm square. Cube, sorry. This is a volume. Okay, so you will see that the correct practice is also the same to this. By using the Pythagoras theorem, we find this BD, and then by the property of the diagonal in the square, we divide it by 2, and then we get the another right angle triangle. We're using the Pythagoras theorem again to find the height. So after this, we can have 1/3 base areas times height. Then we have the volume of this pyramid. Okay, so that's all for this video. I just want to finish 7.1 for part A. Then finish this 3 quick practice and the consolidation corner. And then we already given some worksheet on the E-class. Then you can find to finish this. Okay, if you got any problems, for example, the problems about this video is too not clear enough, or you find something you don't know about the volume of pyramid, then you can WhatsApp me and then you tell me how can I fix it. Okay, that's all.